So let's take a look at this example here that was asked about. So rowing team rowed 60 miles while going with the current. So as I'm reading this, I can tell this is a boat in the water type question where you're going with the current, and I'm assuming afterwards you're going against the current. And you have this statement here, in the same amount of time as it took 10 miles to row against the current. So in this situation, this makes us think of, we have a rate, time, and distance. So some people just say, well, you take a rate like miles per hour times the time like hours, and that's going to give you distance. You can think of this as, let's say you had miles per hour times hours. Hours would cancel out and you just have miles left. So I always suggest using the units to help you navigate. Some people also write this as RTD like this. The only reason they do that is because rate could be distance over time, or time could be distance over rate, or rate times time is distance. Those are all equivalent forms of the same relationship. Okay, so knowing this, we have two situations. We have, and drawing a picture is another strategy. So with the current, so there's the current and the speed of the boat. Say speed. And they're going 60 miles for that first leg. And I'm just mapping out what we know. I'm not really sure where we're going yet. I do, but just if you were just looking at this problem for the first time. And then it's 10 miles against the current. So if they're going this way, they're against this current, right? This current here is negating them, and they're going 10 miles in that amount of time, and it's in the same amount of time. So now because of this, that's telling me I'm probably going to be looking at the time relationship, because it's easier for me to do distance over rate for one case is equal to distance over rate from the other case, because time equals time, and I know the times of these two things are equivalent. In the past, in prior questions, you may have seen the distances are the same, and so then your rate times time scenario gets equated to each other. Of course, this can be done in other ways, but this is the first thing that comes to my mind. The rate of the current was 5 miles per hour. Okay, so we know the current rate is 5 miles per hour. Find the rate of the rowing team in still water. So we're assuming that the rowing team is pushing with their power, their sort of still water speed, the same both ways. So they have a still water speed this way and they have a still water speed this way. But when they go with the current, we can make a little table, for example, and then against the current. And you can map this out in different ways, but let's just tabulate what we know. With the current, we're interested in the distance divided by rate to equal the time, because we're going to be relating the time. So with the current, the distance was 60 miles. And against the current, it was only 10 miles in that amount of time. And the rate was miles per hour. So for with the current, now we have to think of the fact that we had the still speed and the current was helping, in this case, by 5 miles per hour for the rate. So it's whatever their power is plus 5. And then when they're going against the current, this 5 is against them. So it's going still speed minus the current speed. All right, so they have not told us anything about the time, But we do know that the time is equivalent. So if I go 60 over s plus 5, that is equal to the time, the time as calculated through the with the current situation. And against the current would be the 10 over s minus 5. And so we can treat this situation as, well, 60 over s plus 5. So that's miles over miles per hour is going to give me the time, because miles per hour and the hour is going to come up. You can write this in different ways. Like this is one way to represent it. Miles over miles per hour. And again, dividing by a fraction is going to result in multiplying by the reciprocal, and so you get hours. Both of these are in hours. And that's coming back to this situation. So you can go ahead and solve this. There are different ways. You can get a common denominator. You can multiply both sides by s plus 5 and then both sides by s minus 5. You can, some people like to cross multiply, but that's essentially the same as multiplying both sides by the same thing. And so I will let you continue this on to solve the equation, but this is how one way we could set it up. Now, some people might set it up as s plus 5 over 60 equals s minus 5 over 10. That could work. There are probably other ways of getting there, but this is one of the ways that relates directly to the rate time distance relationship. All right. So also when you solve this, just make sure you pay attention to the denominators and the fact that s cannot be 5, and it cannot be 5 because you can't have a 0 in the denominator. So if you do get something that does result in a 0 denominator, you cannot use that value. And same with negatives. Like, I don't think we have a negative rate here, but otherwise they wouldn't be afloat in the water and they wouldn't have traveled. So make sure to still, when you get an answer of s equals something, make sense of that answer in terms of the context. Hopefully that helps you a little bit. Yep. Take care.